Okay, in this video we're going to talk about vector arithmetic. So vectors can be added and subtracted and multiplied by scalars just like other numbers. It's just we have to do it in a different way because we have to account for the direction. So in these examples I'm going to take two vectors, vector A and vector B. Now notice they're drawn as quantities with a magnitude, which would be represented by the length of the vector, and the direction, which is the direction the arrow points. So let's say I want to add vector A plus B together. When we add vectors together, we do something called the head to tail method, meaning I line them up. So I'm going to draw a grid in, so for some reference point, and I'm going to start at my origin. And to add A and B together, I simply line them up head to tail. So I line up them in their direction with their magnitude and see where I end up. So I'm going to start with vector A. So I've drawn vector A in its direction to its length, and then I'm going to take B, I'm going to line it up at the end of A. So there's vector B. So right here I've lined them up head to tail. So this is how I add vectors together graphically. So my result from adding A plus B is a vector C, which is the vector that connects the beginning of A to the end of B. So in terms of vector addition, vector A plus vector B equals vector C. So that's all I have to do to add them up. Now I could add, let's say I added a vector like D into the mix. If I wanted to add three vectors together, I simply add D to the end of B. It doesn't matter. I can add up as many as I want. So I would add D, and I would get a new vector. Let's call this vector E. Okay, so vector E is simply the vector from the very beginning to the last tip of the vector D. So I would say A plus B, vector A plus vector B plus vector D equals vector E. So this is how I line up and add vectors. So I could then measure the magnitude of E, and I could figure out the angle, right? It's really close, but there'd be some small angle here. That would be the theta, the magnitude and direction, and that would be my vector E, which was the result of adding A plus B plus D. So head to tail, adding vectors from the beginning to the end of the last one, as long as you draw them in their correct direction to their correct length, that's how I can add them together. Now I can also subtract A or B from A. So let's show you vector subtraction. And the way we want to think of this, A minus B is the equivalent of vector A plus the negative of vector B. So essentially I'm going to take B and I'm going to flip it 180 degrees. So this is the negative of B. It's just the same length, same magnitude vector in the opposite direction. So to add A plus negative B, I start at my origin, I draw my vector A, and then instead of B coming this way, I add the opposite of B. So B is pointing away like this. Okay. So A minus B is the same as A plus the opposite of B. So my result is, again, head to tail, beginning to end. So let's just call this vector F. So I can say A plus the opposite of B, or A minus B, vector A minus vector B, is equal to vector F. I'm simply adding the opposite. So one other thing I can do, now I'm actually, in this case, not multiplying vectors by vectors. When we get into multiplying like vector A times vector B, we're getting into cross products, dot products. Okay, this is vector arithmetic that is for future courses. So if you're taking future mathematics courses or future physics courses, you'll get into dot products and A dot B and A cross B, right? these are beyond the scope of this course, but for this course, we can multiply vectors by a scalar, and all that means is I double or triple, or by whatever quantity, the magnitude of that vector. So 2 times a, if this is vector a, the scalar product, so 2 is just a quantity, 2 times a, all I do is double a. So I add an a on top of an a. So this is my vector 2 times a. And 3 times b, take vector b, and I just triple it. 3 b's. So this new vector is vector 3 times b. And if I add those together, let's call the result vector, let's see, E, F, G. Again, I just line them together. I'm adding them together. So I line up the 2 A's and I line up the 3 B's, and the vector G is the result of wherever they begin to wherever they end. So I'm going to go, start at my center, I'm going to go vector A, this is my 2A, and then the 3B, vector B, vector B, vector B. Now notice I'm not measuring these. If I was being official, I would actually have to scale these, right? I would get a ruler out and scale them. It's okay for the purposes of this course that you eyeball them, so that at least you know if A is longer than B, then relatively A is longer than B when you draw them together. You should at least make an attempt for those to look close. So the product of adding 2A plus 3B is my vector G, and it would have whatever this theta or angle is, and then the magnitude of G would be the length of this vector. So lining up head to tail when we add vectors together, subtracting vectors, we simply add the opposite of the vector, and then multiplying vectors by scalar, we simply double them or triple them depending upon what that quantity is, and then we add them together head to tail, and the resulting vector is the vector from the beginning of the first one to the last tip or head of the last one, and that's how we do it.